Hello and welcome back to Edu-Malanga. Today we are continuing to do examples on the sum of geometric series. This is lesson number 4 in the first unit of the year, which is patterns, sequences, and series. Today we will do 2 more examples. These will be example 3 and example 4. If you're joining us for the first time and you are unable to follow these examples, please go back and watch the 2 previous videos where we introduced the sum of geometric series and we also did example 1 and example 2. But if you're very confident in your understanding of the topic, then continue with us and let's solve these 2 examples. The first example we will look at today is example 3, and example 3 goes like this. Sum the first 6 terms of this geometric series, and the geometric series is given over here. Let's begin by remembering the 2 formula that we use when we have to sum terms of geometric series. Sn, which is the sum of n terms of the geometric series, is equal to a, open your brackets, r to the power of n minus 1, close your brackets, divided by r minus 1, or the formula can also be written as a times open brackets 1 minus r to the power of n, close your brackets, all over 1 minus r. These 2 formulae are both useful when you are summing n terms of a geometric series. The first one is easier to use again when your r, which is the ratio, is greater than 1, so you have an integer such as 3, or your r is less than -1, could be -3. When you have a number like this for your r, it's easier to use this formula because when you say r to the power of n, you get another big number and you subtract 1, versus with this formula, when you use this one, if your r is a fraction, so your r is equal to, for example, 1 over 3, you will have 1 minus the fraction, and so this formula becomes easier to use. I hope you're understanding and following with me. So to sum the first 6 terms of this geometric series, we're going to use one of these 2 formula. We're going to start by writing everything that we've been given. So let's write what we're given. We're told to sum the first 6 terms. So our n is equal to 6 because we have 6 terms. And when we look at the series, we have the first term, which is equal to a, that's 18, given to us as well. A is equal to 18. We can use the terms of the series that we are given to find r, which is the common ratio. And how we're going to do this is we're going to divide 2 terms that follow each other. We're going to say term 2 divided by term 1. So our r is equal to term number 2 divided by term number 1, that's equal to 9 divided by 18, which is equal to, when simplified, 1 over 2. So we have n, a, and r. Let's come back to these equations. The equation that we're going to choose, because our ratio is a fraction, so we're going to choose the second equation to solve for the sum of the geometric series. Let's rewrite it on the page before we get started solving. We're going to use Sn is equal to a times open brackets 1 minus r to the power of n, close our brackets, all divided by 1 minus r. Let's substitute in everything that we have. We know that n is equal to 6, so sum to the 6 terms is equal to 18 times open brackets 1 minus 1 over 2 to the power of 6, close our brackets, and all of this is divided by 1 minus 1 over 2. We'll start by simplifying what's in the brackets, and we're going to use our calculator to do this. So if you enter into your calculator 1 minus 1 over 2 to the power of 6, what you get is s to the power 6 should equal to, the 18 will stay as it is because we're not simplifying it, 18, and that expression that we said you calculate, 1 minus 1 over 2 to the power of 6, you'll get 63 over 64, and that will be divided by, in the denominator we can simplify as well. 1 minus 1 over 2 is simply equal to 1 over 2. Let's continue. 18 times 63 over 64 is equal to 567 over 32, and all of this will again be divided by 1 over 2. Okay, I'm going to rewrite this expression. 567 over 32 divided by 1 over 2. Remember what we did when we have division? We simply swap the numerator and the denominator of the second term, and then we change the sign to multiplication. So this will then become 567 over 32 times 2 over 1. When we simplify this, the 2 can cancel out and the 32 can be simplified into a 16. So in the end we get that sum of the first 6 terms of this geometric series is equal to 567 over 16. And we've now solved for example number 3, where we were asked to sum first 6 terms of this geometric series. I hope you understood and were able to follow everything that we did. We will now move on to solve example number 4. In example 4, we're given the first term, which is equal to a of a geometric series, and this term is equal to 2. Then we are told that term number 2 and term number 3 added, so term 2 plus term 3 of the same series is equal to 40. Then we are asked to find the sum of the first 7 terms of this series. Let's remind ourselves how series looks. When you have a series to n terms, for example, it's normally equal to term number 1 plus term number 2 plus term number 3, and it keeps on going. Now, let's rewrite these as the variables that they are. Sn, which is again series with n terms. You have a, that's your term number 1, plus a times the common ratio, that's your term number 2, plus a times the common ratio squared, and that's your term number 3, and it keeps on going, and that's how you get your series. So in our question, we were told that a is equal to 2, okay, so a is equal to 2, and we were also told that a times r plus a times r squared is equal to 40, because that's term 2 and term number 3. So we then know that a times r plus a times r squared is equal to 40. Let's substitute a into this equation and solve for r. We're going to have that 2r plus 2r squared should equal to 40. We'll start by simplifying, and how we do this is divide by 2 on everything. Divided by 2, divided by 2. This will cancel out, and we're going to have r squared plus r should equal to 40 divided by 2. That's equal to 20. We need to factorize this expression, and how we do that is we need to move the 20 to this side of the equation. We will then have r squared plus r minus 20 should equal to 0. Let's use our factorization. I'm going to rewrite this expression first in the next page. We have r squared plus r minus 20 should equal to 0. So let's factorize. Open our 2 brackets that we will have. We will have r, and we will have r here as well, equal to 0. And now what we need to do is find 2 numbers that when you multiply are equal to negative 20, but when you add them are equal to positive 1. What are the factors of 20? So to get 20, you can say 10 times 2. Okay, when you add these, they come nowhere close to positive 1, or you can have 5 times 4. With 5 times 4, you can get a positive 1 if you have negative 4. So you then have r minus 4, r plus 5. So the two solutions that we have then are that r is equal to negative 5, because to get this expression to equal 0, you must say negative 5 plus 5, that gives you a 0, or that r is equal to positive 4. I hope you understand. And these are the two solutions that we have for r. Now we were asked to find the sum of the first 7 terms of the geometric series. So let's rewrite everything that we have. We have that a is equal to 2, and we have that n is equal to 7, because we were asked to do 7 terms. Our r's, there's 2 of them, so let's start off with for r is equal to negative 5. We're going to use this equation because our r is a whole number that is larger than a fraction, and so it's easier for us to use this equation. Let's rewrite it. We have that Sn is equal to a times open brackets r to the power of n minus 1, close our brackets, divided by r minus 1. And let's substitute in. S7, 7 terms, is equal to 2 times open brackets, negative 5, and you can keep a bracket in there, to the power of 7 minus 1, close your bracket, divided by negative 5 minus 1. We'll start by simplifying what's in the brackets over here. Again, use your calculator to do this. I'm going to rewrite everything in the next page and simplify this expression. S7 is equal to 2 times, and we're going to use our calculator to simplify what's in these brackets. That's equal to negative 78,126, and that's divided by negative 5 minus 1, which is equal to negative 6. If we enter this into the calculator and simplify again, we'll end up with a final answer of 26,042. So when r is equal to negative 5 in this geometric series, the sum of the first 7 terms is equal to 26,042. There is another r though, remember. We also had r is equal to 4, so let's solve for that as well. We will again rewrite the formula for summing n terms of a geometric series. Sn is equal to a times open brackets r to the power of n minus 1, close the brackets, all divided by r minus 1. Let's substitute in with r is equal to 4 now, n continuing to be 7, and our a is equal to 2 as we saw. The expression will then be 2 times open brackets 4 to the power of 7 minus 1, close your brackets, all divided by 4 minus 1. If we simplify this, we'll simplify what's in the brackets first. We have Sn is equal to 2, do that, times 4 to the power of 7 minus 1. Again, use your calculator to determine that. That's equal to 16,383, all divided by 4 minus 1, which is equal to 3. If you enter this into your calculator, you'll find the final answer that S7, sorry I've been using n when we know that it's 7, yes, is equal to 10,922. And this is when our r is equal to 4. So we've managed to solve the question that asked us to find the sum of the first 7 terms when term 1 is equal to 2 and the sum of term 2 and term 3 is equal to 40. I hope you were able to follow and understand everything that we did with these examples today. Join us again in the next video we will be looking at the sum to infinity for certain kinds of geometric series.